Hello everyone, we are exchange student group and my name is Xingye Tu.
And my name is Ben Wu.
And today we will be discussing some core concepts of operating systems. And my task is focusing on processes and threads, about their differences and how they are managed by the operating system. And the first page is the concept of a process, definition of a process. A process is described as a program in execution, an instance of a program running on a computer, a unit of activity characterized by the execution of the sequence of instructions, a current state, and an associated set of system resources. And next page. And difference between a program and a process. A program is static and consists of code and data, while a process is dynamic, representing a program in execution. And a program do not perform actions independently, but they must be executed by the operating system to become processes. And then is process life cycle and the various states a process may be in. And processes have distinct states. The first is new. A process has been created but not yet admitted into the system. And then it's ready. When the process is prepared for execution but awaits processor time. And then it's running and the time the process currently being executed. And then it's blocked and waiting. When the process is waiting for an event such as the I/O operation to process. And then it's access the time the process has completed execution or has been terminated. And then there's the definition of creating a new progress. And there are 5 steps as follows. And then it's the references from the textbook, reasons for process creation. Um, the first is a new batch job and interactive logon and created by OS to provide a service and spawned by exiting process. And then is the definition of transitions between states. And the first example is from running to ready. When a process reaches its maximum allowable uninterrupted time. And the another example is from running to blocked when the process requires an available resource or event to proceed. And then is the reference from the textbook about all the kind of state transitions, new, ready, running, exit, suspend, blocked. And then how to allocate resources to them. And processes require system resources such as the CPU, memory, and I/O devices. And the OS maintains control tables, including memory, um, and no, the next page. And the OS maintains the control tables, including memory, I/O, file, and the process tables to efficiently manage these resources. And next page is this diagram shows how the OS uses control tables to efficiently manage resources and ensure smooth multitasking by keeping track of memory, devices, files, and processes. And next page is the process control block PCB. And the PCB is first is vital for managing multitasking. It stores and it stores priority and process identifier and A process identifier is unique numeric ID for each process, and priority determines scheduling order. And then program counter points to the text instruction, and the memory pointers it's uh, uh, manage memory allocation and sharing. And next page is the comparison of Unix and Windows process management. The operating system is Unix and Windows, and the process management method is use forked and exec for process creation, and Windows is use create process with thread as main execution units and job objects for group management. The next page. And this is the reference from the website which compared Unix and Windows. And then is the advantages of Unix and separate address space improves stability, scales well when additional be used, and advantages of Windows is threads share memory space for efficient communication. Multi-threading improves execution within a process. And disadvantages of Unix and Windows. Uh, Unix is complex, and Windows and shared memory can lead to synchronization issues without proper locks. And then is the definition of the thread, and then is thread and multi-threadings. And a thread is a dispatchable unit of work that executes sequentially and share resources with other threads in the same process. And there are differences between threads and processes. A process is the basic execution unit, while a thread is an execution unit with an process. And the thread share the processes address space and resources, making them lightweight compared to processes. And then is the advantage of using threads. The first is improved performance, parallel execution across multiple cores. And then is reduced overhead, efficient resources sharing within a process. And there are different models of multi-threading. The first is one-to-one, and each thread of execution is a unique process with its own address and space and resources. And many-to-one is it's simple, but a many-to-one a process defines the address space and the dynamic resource ownership. And one-to-many, a thread may migrate from one process environment to another, and many to many. It combines attributes from many to one and one to many cases they put together. And then and the disadvantage between the thread models. The first is one-to-one model, and each thread maps to kernel thread, enabling strong parallelism. And then it's many-to-one model. It's simple but parallelism. And then it's many-to-many model. Threads can execute it across multiple domains for efficient resources utilization. Next page, and it's well on multi-core systems, and but this disadvantages is complex to implement and requires careful system resource management. And then is the creation of the threads. Threads are created when the OS receives a request from application. And next is the threads termination. They can be terminated by themselves another thread, or when the parent's process ends and threads in the same process communicate through shared memory. And it's synchronization. And a synchronization is an important aspect of thread management. A thread may enter a waiting state if it needs to wait for an event to complete. And then is inter-thread communication, and threads can communicate efficiently, especially those within the same process. And by organizing their common address space and share resources. And that's all. Thank you.
Yes, okay, thank you, Xingye. And then I'm going to introduce concurrency, the race condition, mutual exclusion, deadlock definition, and for necessary condition, deal with deadlock, and three strategies: prevention, avoidance, and the detections. And finally, it's about starvation. So here is about the concept of the race condition. As William starting said, this is a situation in which multiple series or processes read and write a shared data item, and the final result depends on the relative timing of their execution. So this is why it will be arise, because the arise condition occurs when multiple process and series read the right data item. So that final result depends on the order of execution of instruction in the multiple process. So here is very simple example about race condition. If process one wanted to access shared resource and process also wanted to access shared resource, so which process should be first? Then I'm going to give you a very simple example. Process one wanted to access here you can see a global variable, and then firstly process one wanted to access a and update a equals 2, and secondly process two access a and wanted to adapt a equals 3. In this case, race condition occurs because you can see the result is very obvious, because the process is the last process to access the global variable a. So the result is 3. So the need for mutual exclusion to prevent race condition. As William Stalin said, current process come into conflict with each other when they are in competing for the user of the same resource. And each process is unaware of the extent of other processes. And each is to be unaffected by execution of the other processes. And there is no exchange of information between the competing processes. So mutual exclusion is needed for preventing race condition, because it ensures only serial process can access critical section at any given time. So here you can see the software approaches to achieve mutual exclusion. This is Dicker algorithms. These algorithms use both turn variable and the flag arrays. The turn variable indicates whose turn it is enter a critical section, while the flag arrays express the intention of each processes. And here you can see a flow chart. This is the logical about these algorithms. And then about the nested algorithms is Peterson. This algorithms is simplify the Dicker algorithms, but the logical is the same. Okay, about the advantages and the drawbacks. So the advantage, it is hardware independence, and it is simple implementation. And about the drawbacks, it maybe will create busy waiting, and it is limited to instruction level. And now I'm going to introduce the hardware support. The first method is about interrupt disabling. And here you can see the wire loop. This code referenced by Williams starring. And the important things is using primitives, sorry. And it includes primitives disabling interrupts and the primitives enabling interrupts. And when operating system use disable interrupts primitive, the critical section cannot be interrupted. It's very important. And then about the advantage of this is very simple and efficient, and but it will create high prices, and it's only can use in single unit processor. And here about another one, compare and swap instruction. Each series and process try to set the baud equals 0 using this automatic manipulation. This is the basic logic of these methods. Yes, and then about exchange instruction, the basic logical is take 1 for 0. It means use 0 to exchange 1. This instruction exchange the contents of the register with that of the memory location. Yes. So this is about the advantage and the disadvantage. The disadvantage is it will create busy waiting, maybe, and it maybe will create starvation and deadlock. But advantage is any number of processes on either a single processor or multiple processors sharing main memory, and it's very simple and easy to verify. And the supporting multiple critical sections can be defined by their own variables. Now I'm going to introduce deadlock. The definition of deadlock, as William said, deadlock can be defined as the permanent blocking of the set of process and either compete for system resource and communicate with each other. And this is a very simple chart about how it occurs. When process 1 want to access resource 1 firstly, and here you can see, and then process 2 access to resource 2 firstly, and then process 1 to go to access resource 2. But at this time, the resource 2 is occupied by resource process 2. So it will occurs deadlock because process 1 cannot obtain the resource 2 from process 2. And then the 4 necessary conditions for deadlock. So first one is mutual exclusion. Only one process may use a resource at a given time and hold and wait. No permission, correct circular wait. Yes, the final is circular wait. About how to prevent deadlock. The first method is about deadlock prevention. The 4 methods. The first is cancel mutual exclusion. Maybe it's not easy to achieve. And the next one is eliminating hold and wait. It's also very difficult. And the third one is circular wait. And the finally is precaution. So these 4 methods can maybe sometimes can prevent deadlock. And about another method is avoidance. The first thing is process initiation denial. Do not start a process if its demand might lead to deadlock. And the next one is resource allocation denier. Do not grant incremental resource requirements to a process if this allocation might lead deadlock. Here, the reference from the textbook and the specific test content. And here you can see a very single logical from about these methods. And the next one is the resource allocation denier. It uses bankers' algorithms. This involves two states. The first is safe state and another one is unsafe state. And finally is about deadlock detection. The logic of this method is first mark the process that value not being allocated any resources. Initialize the temporary vector W, representing the current variable of the resource, then search for resource who resource needs and then can be satisfied by the current variable resources. Once found, update the temporary vector W by adding the resource allocated to the current process back to W. Continue this process interactively. Search for other processes that can be satisfied by updated resource. If not, process can be satisfied by the arrival resources. It indicates that deadlock has occurred. And then William Stallings mentioned the four methods to recovery. The first, here you can see, and then, yes, this is the fourth method. About the advantage and disadvantage, you can see deadlock prevention. The advantage is it's effective for execution of cascade of activities, no permission. And disadvantage is effective and must be aware for future resource requires. And about preemption, resource foresters easy to protect and reply, but it's too often. And then resource sorting, it does not occupy the running time, but it requires for increase the resource and are prohibited. About that avoidance, deadlock avoidance, the advantage is no preemptions, and the disadvantage is the process cannot be broke for a long time. And about that deadlock detection is the advantage is does not extend the process initialization easy to handle online, but it's the inherent preemption is lost. So the finally is about starvation. So what means about starvation? It is a situation in which a runnable resource outlook identified by SQL, although it is able to process, is never chosen. And I find two methods from the website, from online. The first is first come, first serve. This means process are scheduled according their order of arrival. And next one is shortest job first. This is about each time a process is scheduled, the currently arrived process will be shortest execution time is selected, but it may create starvation. So it's not a good method. Okay, this is the reference resource. This is the book and the online resources. Thank you for listening. There are a lot of contents about our presentation.
Thank you.
Yes.
Yes, we